All right. Good morning, good afternoon, whenever you're watching this. I don't know, but it is 11 o'clock. And today is Wednesday, April 29th. We are at the end of April. Get excited. Woo! All right. So today, what I want to do is I want to do a quick review of and you see it says happy Tuesday. So I recorded this yesterday, but the information at the bottom is what I want to focus on. Okay. So today we are going to continue on with polynomials and binomials, trinomials, all those other nomials that sound familiar. You may be like, I remember hearing that word, but I really didn't know what it was. Today's your lucky day. All right. So again, to anybody that is catching this on the playback, please make sure that you watch this video in its full entirety. That is very important. Okay. Now, don't worry about this date because I recorded this video yesterday, but I want you to pay attention to the bottom. And for Mr. McFadden and Miss Philomena, can you all see the screen, or do I need to make it bigger?
Can you make
That's
it?
fine. That's fine.
Okay. And Mr. McFadden, you want me to make it a little bigger?
Yeah, just a little bit.
Okay. Is that better for you?
Yeah.
Okay. And I need to move this thing out the way. It's always in my way. All right. So, as I said in my playback yesterday, in order for you to be successful in solving polynomials, you have to make sure you understand how like terms and unlike terms work. So, this is a crash course that I'm going to scroll at the bottom here. This is a crash course of like terms, adding, subtracting, multiplying them, and dividing them. Okay. I'm going to start over here. Remember, like terms are like identical twins. Okay. I mean, you can't tell them apart really with identical twins. So I have the example. Let me change my, hold on. Okay. Let me change my cursor here so that way. All right. Uh, all right. Okay. So right here, I have add. So we know how to add numbers, subtract numbers, multiply numbers, and divide numbers. So the good news is when it comes to like terms, half the battle is already done for us because we know how to add, subtract, multiply, and divide numbers because numbers are like terms. Okay. It's when they started adding in the letters and the exponents that made it very like difficult. Okay. So, okay. So with that, we have 3a at the bottom plus 5a, which is equal to 8a. So remember, when you are adding like terms, okay, when you're adding like terms, you want to only add and subtract the coefficients, meaning the numbers that are in front. Okay, so we have 3a plus 5a equals 8a. Here in subtraction, we have 6 minus 4, which is 2. But of course, we add the letters in. That'll be 6b minus 4b is equal to 2b. All right. Now, with multiplying and dividing, it's a little different, but the rules are basically still the same. We know how to multiply numbers. 7 times 9 is 63. We got that, no problem. Again, is when they started adding in these letters and exponents and carrying on. That's when it got a little crazy. So as you can see here, I have 7c and then 9c in parentheses, excuse me. Remember, in algebra, the multiplication sign, the letter x, it goes away and it turns into the variable letter x, okay? Also in algebra, they use parentheses as a sign of multiplication. So anytime you see something in parentheses, more than most times, it will be multiplication. So just make sure that you follow the example that I have here. Okay. Now we have 7c times 9c. Now the answer is really 63c squared, But the reason why I had to write it that way is because I didn't know how to like write the little two in the sky. I didn't know. So that's why I put here the two represents it being squared. Okay. So what does that mean? And I have over here in the middle, when multiplying like terms, you multiply the numbers together and you add the coefficients or the numbers in the, I'm sorry, not the coefficients, the exponents, excuse me, the numbers in the sky, okay, from the letters. All right. And I'm going to write out another example. Matter of fact, let me go ahead and do that now. All right. So for example, if I had 4F and that is multiplied by 8F, okay? So I am multiplying my like terms. They're like terms, again, because they have the same letter. The numbers can be different. The numbers can either be positive or negative also, okay? But we are looking at the letters as it relates to like terms. So when I do this, 4 times 8, I know gives me 32. So that's not a biggie. But what about my F? So remember, just because you do not see it, it doesn't mean that it is not there. So if it helps you, you're going to put a 1 as your exponent. Now remember, they are not going to write it like this on your test because the goal is they think that you should know this, which you do know because I'm teaching it to you. All right. So I multiplied my numbers 4 times 8 and it gave me 32. But now I'm going to add my exponent. So that's going to be 1 plus 1, and that gives me F squared, okay? So that is where our F squared comes from. So I'm going to go back to the first slide because it says when multiplying like terms, you multiply the numbers together and add the exponents, or as I call them, the numbers in the sky, from the letters, okay? So that's very important with like terms. Dividing like terms, you're going to do the same thing, but the opposite. You're going to divide the numbers and subtract the exponents, okay? So my example here was 90 divided by 9. We know that equals 10. That's no issue, no biggie. Again, when they added letters to this thing, it just got ridiculous. So we have 90D divided by 9D. And I will go ahead and go to the second page to rewrite it, so that way you can see it and it can make sense. All right. So I have 90D divided by 90. And also remember, the division sign that looks like this, that is no longer in algebra, okay? It is now in a fraction form. And remember, fractions are nothing more than division problems anyway, all right? So I am going to divide my numbers. 9 goes into 90 10 times. Now, if I divide my numbers, that means I'm going to subtract my exponents. So remember, just because you don't see it doesn't mean that it doesn't exist. It's invincible, okay? So if it helps you again to put a 1 up top to let you know that there is an exponent of 1, please do that. Now, when I subtract 1 from 1, that leaves me with 0. Now, a side of err on the side of caution. Please don't write this. Because first of all, that looks silly. Don't do that to yourself. Your answer will simply just be 10, okay? Where is my cursor? Cursor all over the place. All right. So you do not have to write D to the 0 power, simply because anything to the 0 power is equal to 1. So that's why you don't need to write it. All right. So Miss Philomena and Mr. McFadden, how do you all feel so far? Are y'all still with me?
Yeah. Yeah.
Okay. Miss Philomena, are you still with me? I hope
Yeah.
she is. Oh,
Yes.
okay. Oh, okay, okay. Just wanted to make sure y'all are okay. Now, do not worry. We're going to be doing some practice problems with a lot of these things momentarily. So hang tight. I just want to give you this crash course. All right. Now, I'm going to scroll over if I can see it. Okay, there we go. Unlike terms are fraternal twins, and I'm pretty sure we've seen fraternal twins once upon a time in our lives. We may actually have some in our family, that whole little tidbit. All right. So fraternal twins, they're different. They kind of look alike, but they're different. You can tell they're different. I have written here, you cannot add or subtract unlike terms. That is going to be very important when we start doing this thing called factoring, trinomials, and all that other fun stuff. So remember, you cannot add or nor subtract unlike terms. The examples that I used here was 7b plus 10a or 10a plus 7b. My answer would not be 17ab. That's not how they go. This would be my final answer simply because they have different letters. If they had the same letters, then I would be able to add those together or subtract those. So this again, this would not be 17ab. So don't do that to yourself. This is not the answer. So don't do that. Not the answer. Just like this answer, 10a minus 7b, it would not be 3ab. Again, don't do that to yourself. Okay? That's not cool. That's not your final answer. The answer stands as is. So anytime you see two terms that have different letters, that is your final answer. Okay? Just want to make sure that everybody that's watching this playback understands that you cannot add or subtract unlike terms. However, you can multiply and divide unlike terms. This is where we start using the distributive property and with FOIL and all of that good fun stuff. So I will show you all how to apply multiplying like terms and unlike terms in a few minutes. So stick with me. All right. So I have here, and I'm going to go to the other screen and write it out so that way, you all can see it. Hopefully I got some space. All right. Okay, I don't have space. There. All right. So, for example, I have 8c, and that's going to be multiplied by 9d. I don't know why I keep using 9d, but that's just what it was. Again, you can multiply unlike terms, and these are unlike terms because I have different letters. Remember, the numbers do not matter. We are looking solely at the variables or the letters. If they are the same, you can add, subtract, multiply, and divide. If they are different, you cannot add nor subtract, but you can multiply and divide. So that's exactly what we're going to do. We have 8 times 9, which gives us 72. So we know that. So that's the good news. What do you think my answer would be if I multiplied C times D? What do you think my answer would be? And y'all can jump in and answer the question. And if you don't know, you can just say, Miss Hampton, I don't know.
It'll be CD.
Absolutely correct, Mr. McFadden. It would be CD. So this is my final answer. 72 CD. That's it.
Excuse
Really?
me, Captain.
Yes, ma'am.
So, supposing you are going to separate the 72, and give C what belongs to C and D what belongs to D. How do you go about it?
Okay, are you saying, okay, I just want to make sure I understand your question, Miss Philomena. Are you
Yeah.
saying
So
that,
if 8 times 9 is 72,
mm-hmm,
then it becomes 72 CD. And
yes.
if we are going to divide it, how do we apportion C to its rightful numbers and D to its rightful numbers to get 72?
Oh, okay. Are you asking about the division part
Mm-hmm.
of it?
Mm-hmm.
Okay, I'm getting there. You
Okay.
jumping ahead of me, and I like that, but I'm getting there. Okay, that's why I love y'all, because y'all are so eager. And I appreciate that. All right, now I'm going to use the same example, Miss Philomena. I have to erase some stuff, y'all, because y'all know I write big. Even on this thing, I write big. It makes no sense. All right. Do, 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 do. All right, so I'm going to erase this and I'm going to rewrite it over there because I have a little more space. Just a wee bit more. And I'm going to erase this too, and I'm going to erase that. All right. So remember, in the multiplication of multiplying unlike terms, when I had 8C by 9D, that gave me 72 CD. Okay. So that's my answer for the multiplication. However, if I wanted to divide unlike terms, I can do that also. I'm going to take this one, what I just did, 72 CD, and I am going to divide this by 8C. Okay. So I am going to follow the same rules for dividing like terms. I'm going to apply that to my dividing unlike terms. So what is 8 divided by 72?
9.
9. So I'm going to divide my number. That's what I did. So I got the number part out the way.
Okay.
Now I am going to subtract my exponent. So remember, if it helps you, you do not have to do this part, but if it helps you in the beginning of these things to make sure that they, that they are correct, you can put a 1 next to each letter. Okay. Now, I'm going to subtract my exponents. So what is 1 minus 1?
0.
0. So I do not put C to the 0 power. I do not have to put that. Anytime these things cancel out, you don't have to put 0. Okay. Now, I have another question. Do I have a D at the bottom here?
No.
So because I don't have a D at the bottom, this is the same thing as me saying 1 minus 0. So what's 1 minus 0? Anybody?
1.
1 minus 0. Okay. So my answer would be D. Now I wouldn't put D to the first power. You don't have to put that. Because remember, there is no D at the bottom here. So because there's not a D at the bottom, that's going to be represented as a 0. So I have 1 minus 0, and that leaves me with 1. So my final answer would be 9D. Okay.
Yeah.
So did I answer your question, Miss Philomena?
Very correct. Quite
Okay.
clear.
I like that. Very correct. I think I'm gonna put that on the t-shirt. I like that. Um, thank you so much, Ms. Philomena, for your question. Okay, so this is what I want to do now before we jump into any extra stuff. Okay, because I want to make sure that you all understand how this stuff really, really works. So I'm going to open up a new page. Here, I guess. Yeah, I'm going to open up a new page here. Matter of fact, I'm going to go ahead and did y'all copy the notes for this part right here? Because I'm going to go ahead and erase it. But if all else fails, you're more than welcome to watch the playback for anything that you did miss.
Yeah, I took a screenshot.
Oh, look at you using the technology. I see you, Mr. McFadden. I see you.
I'm still learning it.
That's all right. It's better to learn than to, and it's better to learn and to know than to act like you know it and you really don't. So I appreciate that. I really do. All right. So what I want to do now is I'm going to give you all just a couple of practice problems with adding, subtracting, multiplying, and dividing unlike terms and like terms. So I'm just gonna mix it up, okay? Is this okay? Let me put my new page in there. All right. Oops, you cannot write with an eraser, Miss Hampton. All right. All right. Because once you understand how like terms and unlike terms work, then the next part of this will be very easy. I promise. This will be really, really easy. All right. I want to work on these problems right here. Uh, uh, okay. Uh, okay. And that's a three, by the way, just in case you might have been wondering. Uh, All right. So can y'all see those?
Yeah, man.
Okay. So that's what I want y'all to work on. I just want you to work on these little 8 problems. I'm going to go ahead and cover up the my camera real quick because remember, I don't know how to really cover the camera when it's in this mode. I'm still learning. So I'm gonna give you all about 10 minutes to work on this thing. I'll be right back after these messages. Whoop, and I'm back. All right. So just wanted to just check in on you all and see how you all were doing with these little practice problems. How are they treating y'all? Are y'all understanding it? Are y'all getting it, or does it not make any kind of sense? Talk to me.
Um, got stuck at the six.
Okay. All right. And what about you, Miss Philomena? And I heard another ding, so I don't know.
I finished it.
Oh, okay, okay. Um, and I heard another ding. I don't know who that is, but thank you for joining me. All right, so we're gonna go ahead and go over these particular
No,
problems. Hello?
that was me, Miss Hampton. I had exit out by mistake.
Oh, see, look at me. You look at you getting my hopes all up and stuff. Look at you. I'm teasing. But it's all good, Mr. McFadden. I'm just glad you're still with me. All right. So let's go ahead and go over these particular problems. Okay. So if I can find my cursor. Lord. Okay, here we go. So number one, what's the answer that you got for number one?
10A.
10A. That's it. All right. No fuss, no muss. That's the answer. All right. What about number two?
Uh, 2B.
The answer is actually 2B squared. Okay, so I know exactly what you did, Mr. McFadden. You more than likely subtracted these exponents.
Yeah, that's what I did.
But remember, when it comes to like terms, because you see how I have a b squared over here and a b squared over here. So they're twins. So I'm not going to mess with the twins. Okay.
Oh, okay.
I'm only going to look at the number. So I keep my twins the same and I put my number on my coefficient in the front of that. Okay. So just keep that in mind.
All
All
right.
right. All right. So for number three, yes, I said number three, what we got?
45 F squared.
Yep, 45f squared. That's it. It is 45f squared because we have 5 times 9, which is 45, and we have our exponent of 1 here. Remember, I did not write it because that's not how they're going to present it to you, but if it helps you, that's what you do. So we have 1 plus 1, and that gives us 2. So 45f squared is the correct answer. All right. What about number 4? What's my answer to number 4?
13.
Hmm?
13.
13?
Mm-hmm.
Okay, so we have 78 divided by 13. So what's 78 divided by
It's
13?
it's
Okay.
6.
6. Oh
Yes,
my
it is
God.
6.
It's 6.
All right. So now I did my number. So now I have g to the third over g to the third. So what's 3 minus 3?
0. So it's just
0. It's
so it's
just
just 6G. Yeah, it's 6. Okay.
No, it's not. It's just only 6 because remember these
It's only
are
6.
my. I'm sorry.
Just 6 alone.
Yes, it's only 6 alone because when I subtract my exponents, which is 3 from 3, that leaves me with 0. So in essence, these cancel out. Okay.
Okay. Well, I just had 6 on my paper, so
Okay. All right. Well, then you own it. Then that's just what's important. You own it. All right. Now, you know, Miss Hampton is very known for throwing curveballs. I can't always give you easy stuff. That's just not how I operate. So with that being said, I wrote really okay. I wrote number 5 and number 6 on purpose that way for a reason. Okay, remember there is a method to my madness, so y'all should know that by now. But what is my answer to number 5 though?
13.
13.
Nope.
Wow.
Ask your, ask yourself this question. I'm now dealing with unlike terms because I have a F and a G. Are they the same?
No.
No. So because they are different, my final answer, remember we talked about you cannot add or subtract unlike terms? That is my final answer.
As it is.
Okay.
As it is. So
Got
remember, yep, you cannot add or subtract your unlike terms. All right. So, Mr. McFadden, I think you said you got stuck on number 6.
yeah.
All right. I want you to tell me what why you got stuck on number 6. I'm just curious. Not to put you on the spot, but I'm just curious.
Uh, no, well, cause I added it. I mean, I added it.
Okay.
Just wanted to make sure I was right. I mean, I got 33 v 8 squared.
Okay. Now, let me ask you a question. Remember, when we're dealing with unlike terms and like terms, they have to be the exact same thing, right? So look at number 2. You see how we have a b squared here and a b squared there?
Yeah,
Here a
it's
b
not the
squared, there a b
same.
squared. Yeah, so these are the same.
So
These down here for number 6,
shit.
they are not.
Okay,
So my final answer
is is what it already is.
is what it already is. Yep.
You mean in number 6?
Yes.
Wow.
So
Why?
number why? Because I have
Unlike
unlike terms. Now I have the same letter, but I have a different exponent.
exponent. Okay.
So remember, everything has to match. That's the key. Everything got to match. V to the fifth and V to the third, they don't match. So that's the reason why my final answer would be 19V to the fifth plus 14V to the third. That's it. Does that make sense?
Yes.
Yeah.
Okay. All right. See, again, I had to throw a curveball at you because that's just what I do. Now,
Number 7 the same then. It's the same.
nope.
No, I'm talking about it's that you just write it out.
Uh-uh.
You have this.
See, remember, I've been doing this a long time. I don't want you all to confuse the rules. So stay with me.
Okay.
What is 12 times 6?
72.
Okay. What is R squared times S squared?
RS
Excuse
square.
me. Is that 5 or X?
Right here, that's a S.
Okay. Looks like 5.
Yeah, my apologies, Miss Philomena. I promise I'm going to do better with the handwriting. Promise. That's my final answer.
72.
Because remember, you can multiply unlike terms. You're going to multiply the numbers together and you're going to put the letters together in alphabetical order. Okay? So this one wouldn't stand alone. You literally could do this
Okay.
one. Okay.
Gotcha.
All right. We cooking with gas. Y'all doing good. No worries. Y'all doing real good. All right. So the last one, we have 42 m to the fourth power n to the third power divided by 3 m to the third n. I know it's a lot, but we're going to take it piece by piece. And if that's how it helps you to solve these problems, that's exactly what you do. Okay. So first, we're going to start with the 42. Oops. 42 divided by 3. So what is 42 divided by 3?
14.
14.
Mm-hmm.
Okay. My next step is to focus on my 4 and my 3. Now remember, all of these are unlike terms, but I'm going to follow the same rule for dividing like terms. So I'm going to subtract my exponent. So what is 4 minus 3?
1.
So I have 1m left over. And what is 3 minus 0? I'm sorry, not 0. 3 minus 1. Sorry, my bad.
2.
2. So now my final answer is 14 mn squared.
Yeah.
Okay. So these are really not that bad. Not that bad.
Thank you, Miss Antin.
You're very welcome, Miss Philomena. How do you feel, Mr. McFadden? Does it make sense now?
Yeah, getting there.
Okay. Well, I'm glad you're getting there. Just stay the course because you got it.
All
Okay.
right.
Now, okay, it's 11. I can't see Jesus. Okay, it's 11:45. So this is what I'm going to do now. I am going to, and of course, I'm going to email you all a worksheet that deals with nothing but like terms and unlike
Good.
terms because I want you all to practice with that. Because again, this is going to make a lot of sense when we start talking about binomials and trinomials and all that other nomial stuff. Okay. So I'm going to email you all a worksheet for practice. But I have 15, I have actually 10 more minutes. So I want to introduce you to one more thing. And then that's going to be the end of that. I need a nap. It's been a long day. I think
Excuse
it's
me,
this.
Miss Antin.
Yes, yes, ma'am.
Can we get the notes on the playback?
Yes. Absolutely.
Okay.
Uh-oh. I did not mean to do that. Well, I did, but I didn't mean to do that. Okay. Uh-oh, wait. No.
Is that
Yes, sir.
when will we be getting the worksheet in the
Um, as
email?
soon, as soon as this session is over.
All right.
So don't worry. Give me if you give me 10, I'll give you the rest of the day. I promise.
All right.
So I'm gonna get that for y'all. I promise. See this? Okay. All right. So can y'all see that, or do I need to make that bigger? Oh, make sure. Can y'all see that?
Yeah, man.
Okay. All right. So, oh wait, I didn't. I'm not. Okay. Not that's not. Okay. This is the one I wanted to introduce y'all to. Okay. That other one was for something. We'll say that before tomorrow. All right. So real quick, this is also in the playback from yesterday as well. So, like I said, this is just a breakdown of what I talked about yesterday. Um, okay, that's better. All right, there we go. So here's another crash course of all the nomials, because there's all types of nomials around here. Remember, nom, N-O-M, means name, but for the sake of conversation and us talking about different terms and such, I'm going to use the word term. Okay. So these are the different types of nomials that you may see or you may have seen, and it's just been a while. So starting with monomial. Mono means one. So a monologue, somebody talking to themselves, it's a one-sided conversation. Nom means name. So a monomial has one term. It means one term. Okay. So for example, the number 3 is a term by itself. The letter X is a term that's by itself because there's only one is only one. But I can also put x together, and that can be represented as a monomial. Okay? So remember, monomials means one term, is just one. Binomial, now we know that bi means two, so a bicycle, two wheels, bilateral, two-sided, something that has two sides. And nom means name, so binomial means two terms. So the examples that I wrote was 3x plus 6. So I have one monomial with 3x, and then I have another monomial with 6. Can I add those together? Can I add 3x plus 6 together?
Yes.
I can?
Yeah. You just have to keep the exponent right.
No, I'm looking at this one, Mr. McFadden, and I'm looking at 3x plus 6. So my question is, can I add those? Let me write it down here. That way you can probably see it better. Okay. So can I add those together? Can I add 3x plus 6? Oh. Hello? Is it me you're looking for? Are y'all still on with me?
Nah, no, you can't.
That's right. I cannot. Very good, Mr. McFadden. Because these are unlike terms.
Like
Okay.
yeah.
That's right. Very good. All right.
I had
Unlike
to
terms.
refer back to my notes.
Okay, that's all right. That's why you got them. You know, they're not there for decorations. You got them because you need them. All right. So these are unlike terms. So no, I cannot add those together. Okay. So that's excellent. I'm glad you caught the connection with that. All right. The next one that I have here, which is what we're going to get into tomorrow, but I'm just introducing it to y'all now. And again, you can watch Tuesday's playback video with a more thorough, I guess, explanation of these things. So that way, tomorrow, you all can be prepared for this. All right. I have a binomial here. So x minus 9, that's one binomial, and that's multiplied because by 3x minus 8. So I have two binomials here, and I can multiply these things together. So tomorrow, we are actually going to be jumping into this thing called FOIL. Does that sound familiar to you, Mr. McFadden?
No.
Okay. Well, tomorrow's your lucky day. All right. So, but I'm multiplying two binomials here because I have one binomial minus one. And remember, these are still unlike terms, so I really can't do anything with these, but I can multiply unlike terms. We'll get into that tomorrow. All right. Trinomial, we know tri means three. A triangle has three sides. Um, a tricycle has three wheels. So a trinomial has three terms. Now, the example that I wrote here is a quadratic expression or a quadratic equation. So what I wrote in the blue, if I can find, I wrote x squared plus 10x plus 25. Now, remember, these are all unlike terms. So I cannot add this x squared to this 10x. And I cannot add this 10x to 25. These are all unlike terms. So I can't do anything with them. Okay. But what I could do, and what we are going to get into, I can factor that. I can factor that. I can break that down and make it smaller. But we'll get into that momentarily. All right. And last but not least, We have a polynomial. Now, poly means many. So a polygon has many sides. Um, Watch the playback video for my other example of poly. I'm not going to get into it here, but feel free to watch the playback video for more examples of poly. All right. And known means name. So a polynomial has many terms. So a polynomial can look just like this. And I know it's long, but that's what it is. Okay. All right. So I have 5x to the fourth plus 4x to the third plus 3x squared plus 2x plus 1. I cannot add any of these things together because they are all unlike terms. Okay, so I'm going to put an arrow there. Unlike terms, okay? So remember, a monomial has one term, a binomial has two terms, a trinomial has three terms, and a polynomial has many. Okay, so your homework assignment is I'm going to send you all that worksheet. So be on the lookout for that. And for anybody that's watching the playback, please make sure that you watch the Tuesday's video and Wednesday's video and see if you understand how these like terms and unlike terms work. Because tomorrow is not only a brand new day, but we are going to multiply monomials and binomials. We're going to be doing a lot of multiplication. So it's very important that you make sure that you understand how to multiply like terms and multiplying unlike terms. So we're going to take that particular piece and we are going to apply it to tomorrow's lesson. All right. So, Mr. McFadden, how do you feel about today's lesson?
It was good. It was good. I'm catching on.
Okay.
Hopefully, his homework worksheet is it'll bring it out. It'll bring it out me tonight. So
It will. But I'm not even worried about it. It will. It
yeah.
most definitely will. I'm going to go ahead and stop screen share. All right. And Miss Philomena, how about you? How did you think today's class went?
It's good. It's
Wo-
understandable.
Wonderful. And again, I really do appreciate you all's consistency. I really do because without y'all, I can't do what I do. So again, I really do appreciate the both of you all just taking an hour, out of your time just to spend a little bit of time with me and just know that again, my prayers are with you and your families. Just know that we are going to get through this thing together. I promise you, we will. And once I get some more information about GED testing, a lot of students have been asking me, they think Miss Hampton knows everything for some reason. Once I get information about testing centers being reopened and all this other stuff, because I've been hearing that may happen soon, but I don't know. I'll definitely keep you all updated on that. So please continue to save your money for the GED test. Continue to study, watch the playback videos, um, do all the work that I give you, and everything will be just peachy keen.
Bye.
All right. So I will see you all on tomorrow. Y'all have a good one.
All right.
Bye.